Can everybody hear me okay? Yes, that seems incredibly loud. My name is Currie, and I am one of the co-founders of Force12.io, which is a container investigation project, an open source project that we're doing to investigate what containers can do and where they came from and what they can do beyond Docker, which everybody goes crazy about and knows all about. So today, I'm going to take you on a bit of a trip through time. So, in honour of Doctor Who that returned to our screens, obviously, this week with an episode that was okay. Wasn't one of the greatest, but it was okay. So what I'm going to do today is talk to you a little bit about where we've been in software and in dev and ops over the past couple of decades, and where I think that means we're likely to end up. So this is a little bit of a philosophical talk. It's a little bit of a psychological talk. I'll be around afterwards for drinks. So if anybody wants to come and disagree with me, then I'll be very, very happy to speak to you. So yes, as we go over time, we've had one recurring nemesis in software, and this isn't telling you anything you don't know. It's lack of stuff. And at the roots, that's usually lack of bandwidth, or it's lack of CPU, or it's lack of memory. And there's nothing exciting about that. We all know that, and we all cope with that every day. The interesting thing is often how we've dealt with it, what we've done over time to battle against that lack, and how we've approached it. And that's changed quite a lot. So if we look over the past 20 years, we've had three key ways that we've battled lack of anything in technology. The first is specialization. It's coming up with its optimization. It's coming up with a cunning plan to find a better way of using whatever we've got. That's the kind of heroic. You come up with some amazing scheme, and then you go home and you think, bloody hell, I am fantastic. So in many ways, optimization and specialization is a great approach. The next approach is physics. That's the Deus ex machina approach, where we just basically wait for solid-state physicists to come up with better ways of providing us with stuff for the same amount of money. So that just gives us more bang for our buck. But really, as developers or operation people, we don't get that involved with that. We just wait for that to appear. That's manna from heaven. That's a Deus ex machina weapon that we've got there. And the final one, which has become, well, I'll talk about that later, but is actually, rather than going for the hugely cunning plan scheme, we simplify and standardize so that we can spread the problem over a larger number of eyeballs and get loads and loads of different people looking at it. And then either one of them comes up with a cunning plan that we all use, or it just evolves out of the fact that lots and lots of people are making small progress on the problem. So those have been our weapons, I would say, that we've been using to battle that particular nemesis. So now I'm going to quickly take us back in time, and this is more of a Kurt Vonnegut than a Doctor Who. It's more of a quantum leap. We're just going to zip back and forth in my career in IT, which is around 20 years that I've been a professional developer or ops person. And we're going to start at more or less the beginning of my career in 1995, when another analogy, not the Stone Age, the Dickensian times, we had Dickensian poverty. We had about 1,000 times less of everything than we do now. But otherwise, we were quite similar. We wanted the same kind of things. We had the same kind of education. We were the same people. But we had 1,000 times less stuff to play with. And what we did with that is quite interesting, which is that we completely and totally relied on the weapon of specialization. That was really the only tool in our toolbox, was to come up with a very cunning scheme for how we were going to get every last bit out of every byte. And that's not hyperbole. We really cared about every bit in every byte. And what did we do? Well, we used an awful lot of very compressed protocols like ASN1, which I hope never to see again, and hopefully not that many of you have seen it, that were not human readable, that were very, very difficult to debug, to use, to write, but they were very efficient. So they used almost no bandwidth, and they were very easy to construct. They were cheap to construct, and they were cheap to parse in terms of your CPU and your memory. We used languages like C that were very close to the bare metal. So so effectively, we could use those languages to massively control every single byte that we were using on every single CPU cycle. We used clever distributed architectures, which obviously we're hearing a lot more about now. But basically, because they were our only option, you just couldn't, unless you were going to buy a mainframe, you couldn't buy a machine that was big enough to scale that much vertically. You had to scale horizontally. And we didn't go in for infrastructure as code. Everything was massively manually tuned, and hardware was chosen to be very specific to the tasks that we were running on them. So everything was really, really hard. It required an incredible amount of specialist knowledge to get where we needed to be. So, I mean, that had lots of it worked. It was fine. What was wrong with it? Well, it was incredibly slow, was what was primarily wrong with it. It was slow to develop code. It was slow to deploy applications. It was very, very slow to debug them when you're trying to read message flows that are not human readable. It takes flipping ages. You really want to be moving forward with this, and you're not. It was incredibly slow. Most of the code was very unreusable, so it didn't encourage a shared way of working, because it didn't really occur to you that you'd share your code with other people, because it was incredibly optimized for your particular use case. So that was the downside of that. It was 1995. What have we done since? Well, in the 20 years since, I have to say, we have leaned very, very heavily indeed on solid-state physicists delivering results for us. We've seen 1 to 2 times improvements every year in what we get for every pound we spend. The interesting thing about that is what we've done with it. We haven't used that additional power and that those additional resources to go faster, particularly. We have a little bit, but it hasn't been our prime focus. We haven't used it to cut our costs. And again, that would be an obvious thing, but we haven't used it for doing that. Instead, we've used it to go faster and to make life easier. Almost the first thing we did was throw away those protocols like AS&1, which were incredibly frugal, and move to incredibly profligate protocols like XML that were human readable and latterly JSON. That were human readable, and that made it much, much easier to write software and get it talking to one another, to divide up your services and not immediately hit a buffer as soon as come to a full stop as soon as they didn't talk to one another. You could move much, much more quickly. You could cooperate with people in other teams. You could get things working much faster. We moved away from protocols like H323, which were, again, very efficient and very powerful, but very hard to write, and moved to things like SIP. And we wouldn't see I don't believe we would see all of the VoIP clients and tools that we have today if we were still building that on quite complex protocols like H323. We used the fact that we didn't care so much about efficiency, and we actually started to use this additional space and this additional room for maneuver that we had to build simpler stuff to get us all the range of applications that we have today. And we moved. And I do think this plays a big role in the move away from manual optimization to infrastructure as code, because yes, we don't have. I still think that if you would get more bang for your buck, potentially, if you were manually tuning every single server that you had to meet the requirements of the particular applications that you were running on them. But it would be incredibly slow, so it would have other downsides, and it would be difficult. So we're moving away from that, and I believe rightly so. All of this represents a huge cultural shift in technology for the past 20 years, at least, that I've seen, which is away from specialization, taking advantage of the gains of solid-state physics and all those clever folk in labs. And it's enabled us to bring in, to take an approach which is more standardized but less efficient. So with a more standardized code, we can share it, we can reuse it, we can get everybody's eyes on it and generally make improvements by scaling horizontally in terms of brains rather than vertically in terms of brains, which is what we were doing. And I don't think agility or leanness would even be such an option if solid-state physics hadn't delivered for us in the way that it has. So overall, it's a massive move towards speed over efficiency. This seems to be the zeitgeist that we've moved it over for 20 years, and I don't see it changing. I see us halfway through, at best, this move. We're not going to move back. So what does this mean about the present day? Well, right now, the big hot topic in dev and ops and DevOps is containers. And if you talk to developers about containers, they'll say, oh, they're fantastic. They were invented about 2 years ago by Docker, and they're all about faster and easier. That's their whole reason. Yeah, I can take my code, which is sitting in dev, and I can move it into test, I can move it into production. It's absolutely fantastic. That is what Docker, that is what containers are all about. Ease of use, the easier, they're faster, and that's absolutely fantastic. And you'd think, well, actually, that seems perfectly sensible because that's completely aligned with all of the zeitgeist of the past 20 years in technology. It's to move towards easier and faster. So you can see why people like Docker and containers. You can absolutely see where that came from. But the interesting thing is that that isn't when containers were invented, and it isn't why containers were invented. So containers were invented about just over 10 years ago by quite a variety of different companies got involved with this. Google, obviously, a lot of it was done at Sun. And they were invented to massively improve the efficiency of data centers. They were entirely a weapon of optimization, or they were very, very generally a weapon of optimization. And why were they such a good weapon of optimization? Well, one thing about them is they're incredible lightweight. So rather than with a VM, obviously we know the benefits that we got from VMs. But with a VM, you're still running a guest operating system on top of a host operating system, which means that you've got a lot of wasted resources in there. But with a container, it's a lot more shrunk down, so you don't have all of those overheads. So innately, you've got the potential to massively increase the efficiency of the use of your data center resources. The other thing that's very interesting about them is, well, actually, the next thing that's interesting about them is the encapsulation. The way that you can easily move things, and this is exactly what developers like about them is right. They can be easily moved from dev to test to production. And the final thing that really that helps pull everything in together is their speed of instantiation. So you can bring up a container in seconds, or even less than seconds, whereas a VM, it's going to take you minutes. And on the one hand, that's just, yeah, it's 100 times better, that's good, that's fine. But really, the power comes from that. The power in that comes from the fact that you're crossing a Rubicon in terms of your main source of demand, which is people. People sitting in front of their PCs, people sitting in front of their mobile phones. Say they want to log into your system to find out what's happened to their favorite star who's just been in an embarrassing naked motorcycle accident. They will be prepared to wait a second while your systems reorganize themselves to satisfy this unusual and totally unprecedented demand. But they won't be prepared to wait 3 or 4 minutes for your systems to reorganize themselves to address that demand. So suddenly, because of the psychology of the people who are using your systems, the prime source of demand that you have, containers are a particularly powerful technology because they take the ability to change what you've got running in your data center from minutes to seconds. And that crosses this Rubicon of what your users are willing to wait for. So, and then when you combine that with the encapsulation, so developers like containers because they're easy to move from dev to test to production. Why ops people should like containers is because it makes it easier to move your containers around between servers in your data center. So actually you can start to make decisions about where particular workloads should be running, particular applications should be running, to make sure that you're packing, you don't have any resources left unused in your data center. And this is what Google do. So Google use this to get around 70% utilization of the capacity in their data centers, which is astonishing when you consider that the worldwide industry average use of capacity in data centers is between 10, 15, 20%. So just a complete world away from what Google are achieving. And they're doing that with containers. And if you want to find out more about what they're doing, the Borg paper or the Omega paper are very interesting. Now, it's not just Google who are doing this. So Netflix, who are actually running on Amazon, underlyingly an Amazon infrastructure, they've got about 50%. Apparently, it's very difficult to get from 50% to 70%. It's very difficult to get 50%. And I wouldn't immediately recommend that anybody do it because it is phenomenally difficult. But it shows that it is possible. And I think in the future, we will be wanting that for ourselves in our own data centers. So now I'm going to give you a demo of what kind of things they're doing at. This is a live demo, so let's hope it vaguely works. So this is something we've built at Forstolf. So here we go. So this is the kind of thing that we're talking about. So this is the demo that we've built, and it's running live at the moment on, this one is EC2, where we've installed a 3-node Mesos Marathon cluster, and we wrote a little scheduler. And what it does is we randomly generate demand, which is in red, and we've told our scheduler it wins if our number of high priority containers meets the demand, and our number of low priority containers fills up the rest of the capacity. So we'd be winning, that's a win, but that's a win. So we're actually quite close to being able to utilize the full capacity of our particular cluster that we have as we've defined it. But this shows that actually it is possible to do this kind of thing. With the use of clever schedulers, you can be constantly reorganizing the workloads on your servers within your data center to increase the usage of your capacity, to better use the capacity that you've got available to you. Now, I saw Kelsey Hightower a couple of weeks ago give a demo using Tetris for this. But I'm afraid my Tetris skills are absolutely not up to playing Tetris live in a talk. But this is really what they're doing, a vastly simplified version of what Google are doing, and Netflix actually. There we go. Now I need to go back to my talk again. So yes, where do I see this going? Where's the future of this? Well, right now, nobody has data center capacity utilization or data center efficiency as a KPI, and thank goodness for that, because we're in no position to achieve those kind of 70% targets. That would be crazy talk. But as we move more towards using towards the data center as operating system model, and it's going to be much more apparent how much resource you have and how much resource you use, I think this is going to eventually become a KPI. This is something that we are going to care about. What is the what efficiency are we achieving in our data centers? And I don't think, and Google and Netflix suggest that 50, 60, 70% is not impossible. Now, don't even think about doing this now, because right now, doing this kind of stuff involves incredibly complicated DevOps, and it will take up you'll have to have a shit-hot DevOps team, and it'll take up all their time, and it'll be amazingly costly. So don't do it yet. Unless you have huge savings to be made, like Google or Netflix. But the tools will get better. And over the next 6 months, 12 months, the tools that will enable you to do this will get good enough and stable enough and solid enough for everybody to be running in their own data centers. And containers are not going to go away, because they are so aligned with the zeitgeist of faster and easier. They are going to win. You're going to get more and more pressure to use containers within your data centers. And developers will be incredibly happy because they see containers as being all about easier and faster, and they'll be super happy about that. But as ops folk, you can actually know that secretly they give you another advantage, which is efficient use of your resources. Now, devs don't care about that because they don't really see the bills. But if you're in ops, you do see the bills, and therefore you do care about this kind of stuff. So this is just a heads up that I think this is coming. It won't be immediately, and you shouldn't jump into it straight away, but I think this is probably coming. So that's it. Anybody got any questions?
I actually have one way over here too, so you can't see me probably.
I can just about see you.
When you talk about utilizing all the capacity, you're talking about network, RAM, and CPU all at the same time?
Yeah, you have to have really quite complicated schedulers to do that, but Google do that. is my understanding is that they have ridiculously complicated schedulers that basically work all the time to optimize across all three, so that they're trying to get the absolute, the optimum use. So rather than just optimizing for one particular one. But I think for most of us, this is futuristic stuff anyway. But I think we'll get there slowly by probably optimizing one or two to start with, and then add in more and more as more complex schedulers come along.
That was really interesting. We've heard a lot about kind of cloud era, cloud native today, and what you've talked about kind of doesn't quite align from a cloud point of view. So how do you see the two converging? Cloud, so hosted solutions and things that people are making money from, and efficiency, people who want to reduce their bills using containers. Is that something that you think providers would actually give us?
Well, it's interesting because I would have kind of thought, oh, well, this is something that only really people who are running their own data center like Google will care about. But it's interesting that I would say the next most advanced people after Google on using this stuff and schedulers is Netflix. And they do run in a cloud environment. They run on AWS. So, and what they're looking to do is saying, well, I've got to buy all these AWS instances. I don't want to buy more than I need because it costs me a fortune. So it's worth me layering containers and my own schedulers on top of my cloud infrastructure, because it still cuts my bills in half or more.
But do you think the cloud providers will kind of move into the space of providing things as containers?
Yeah. I think they will. I mean, I think, well, obviously, GKE is very containerized, and they really, really want you to, that is completely containerized, and they want you to go in that direction. ECS is also, it's a bit flaky now, but I think it will be fantastically good in the long run. But in the end, they want you to spend more money. They don't want you to spend less money. So to a certain extent, using schedulers and things might be something you choose to do on top of their infrastructure, rather than them providing.
For prioritizing other resources. You mentioned CPU network and memory, but there's also latency or the actual business cost. I don't want to run all these services. I will let users a bit slow today. It's a weekend, don't really care. Do you think there's going to be more metrics kind of pop up?
I think there's going to be tons of metrics that pop up. Yeah, I think you're right. I think that that the schedulers that run on top of this will be a whole new technology set of technologies that allow you to optimize for all kinds of different things. They'll be quite simple to start with, but they can be really quite complex as time goes on.
Can I add to that question? So you asked about latency, but latency occurs outside of the data center more often than inside of it with routing and things like that. I mean, are we actually talking about extending beyond the borders of the data centers to have systems that work better and adapt across the entire network?
That would be lovely, wouldn't it? That's a bit ambitious, even for me. But why not in the long run? Why not? If we start making this the way that we're thinking about things, then why not expect systems to be a little bit more adaptive? To a certain extent, SDN and those different ways of making your network more responsive is going in that direction too. So that's not my area, but I could see it possibly happening.
I suppose you could also do cost arbitrage across multiple cloud providers using a similar kind of scheduler. Have you looked at moving workloads over larger distances than just from one machine to another?
We haven't, but that doesn't mean that I don't think people are. I think this, I was talking to one of the big VCs in Silicon Valley last week about this, and he was saying this is about to become a hugely hot area. Everything that's coming across my desk is about scheduling. So I think there's going to be a whole load of interesting stuff coming up to do with, things like arbitrage. Yeah.
Thank you again.